How do coil turns impact Faraday's law in electrical engineering? Have you ever wondered how the number of turns in a coil can change the voltage produced in electrical devices? This is a fascinating topic that connects directly to Faraday's law. Let's break it down. Faraday's law tells us that an electromotive force is created in a coil when there is a change in magnetic flux passing through it. The number of turns in the coil plays a key role in determining how much voltage is generated. Simply put, the more turns you have, the higher the voltage. To understand this better, we need to look at magnetic flux. Magnetic flux is calculated by multiplying the strength of the magnetic field by the area that the field covers and the angle between the field and the coil. When this magnetic flux changes over time, an electromotive force is induced. The formula for calculating the electromotive force in a coil with multiple turns is straightforward. Electromotive force equals the negative of the number of turns multiplied by the rate of change of magnetic flux. The negative sign indicates the direction of the induced electromotive force, but the amount of voltage produced is directly related to the number of turns in the coil. Each turn of the coil experiences the same change in magnetic flux, which means they all contribute to the total voltage. This is why increasing the number of turns leads to a higher induced voltage. In practical applications, this principle is essential for devices like transformers, inductors, and electric generators. For instance, in transformers, the voltage in the secondary coil depends on the number of turns compared to the primary coil. By adjusting the number of turns, engineers can effectively control voltage levels. In inductors, having more turns increases the inductance, allowing the device to store more magnetic energy. In electric generators and motors, the number of turns affects the voltage and current produced. However, there are trade-offs to consider. While more turns can lead to higher voltage, they also increase the resistance of the coil and its physical size. Engineers must find a balance based on the specific application. In summary, the number of coil turns significantly impacts Faraday's law by increasing the induced electromotive force proportionally. This makes the design of coils a vital aspect of performance in various electrical engineering applications.